Welcome to the deep dive. Today, we're diving deep, really getting into the core of enterprise software.
Yeah, looking at those fundamental building blocks.
Exactly, the things that power those massive business applications we all interact with. And our way in, we're looking at the world of ABAs. Specifically, we'll be peeling back the layers on practice questions for the CBAPD 2507 exam.
That's right. And while, these questions might seem purely for certification, the real mission here for you, listening, is to pull out some critical knowledge.
It's more than just the exam prep.
Absolutely. We're aiming to uncover how these large-scale systems are designed, for performance, for quality, and critically, for security.
Right.
So by breaking down these questions, we'll find these little nuggets, these insights about data handling, modern architecture, system reliability, stuff that's valuable way beyond the exam room.
Whether you're a developer or just curious.
Exactly. And our source material for this is a collection of these official practice questions and, importantly, their explanations.
Okay, let's get into it then. Just to set the scene quickly, this exam, it's pretty rigorous.
Oh, yeah.
We're talking 80 questions, 180 minutes, and you need a 65% score to pass. So definitely not trivial.
A walk in the park.
But beyond the test, these questions, they really highlight some essential practical stuff about ADAP's core mechanics. So let's start right there at the beginning. Data.
Always data.
Always data. When you've got huge amounts of information in these big systems, what's like a common bottleneck, and what's a key command to help deal with it?
That's a great place to start because efficient data handling is just paramount. A classic issue is needing one specific piece of info from a big chunk of data you've already got in memory in an internal table.
Okay.
And our sources point straight to read table.
Read table.
Yeah. This lets you grab a specific row directly using a key or maybe an index.
So no need to loop through everything.
Exactly. That's the core insight. You avoid iterating through every single row. Think about it. It's like using an index in a book versus reading page by page.
Big difference in speed, I imagine.
Huge. It can be the difference between seconds and, well, minutes, or even worse in really high volume scenarios.
Wow. Okay, so that direct access is clearly a game changer for performance. But is red table always the answer? Or are there times when maybe something else is better? Like for really small tables?
That's a fair point. Look, for targeted single record lookups, read table is usually your best bet.
Right.
For tiny tables. Maybe a simple loop is fine. Performance difference might be negligible.
Yeah.
But more importantly, if you need to process, say, multiple records meeting some criteria, then you'd probably look at loop app with a where clause, or maybe even more modern stuff like ABAP SQL, if you're hitting the database directly. Those handle bulk operations much better.
So it's about picking the right tool for the job. Read table for precision finding.
Precisely. Not for processing the whole lot.
Got it. Okay, that makes sense. So we've optimized how we fetch data. What about actually building the software components that use that data? The logic blocks. How does ABAP let developers create those dynamic pieces?
Right, creating those building blocks. Well, in ABAP, the fundamental command for that is create object.
Create object.
Yeah, that's how you instantiate, bring an object to life based on its class definition.
So it's more than just syntax.
Oh, much more. It's really the gateway to object-oriented programming in ABAP. It lets you build these reusable, self-contained units.
Modules? Sort of.
Exactly. Modules that hold both data and the logic to work on that data. And that modularity is just crucial in big enterprise systems.
Why is that?
Well, it simplifies maintenance, right? You can reuse code across different applications, and it just makes these incredibly complex systems more manageable. Think Lego bricks versus carving something from one solid block.
Okay, yeah, I get that analogy. So objects give us the structure, but what about the raw materials, the basic types of information these objects work with?
The fundamental data types.
Yeah, what are the bedrock types in ABAP?
Okay, so for the absolute basics, ABAP has built-in types like CHR for character strings, date for dates. Pretty standard stuff.
Right.
What sometimes catches people coming from other languages is what isn't directly there. Like there's no DEC type directly.
Oh.
You'd use something like P for packed number, or maybe DC float for decimal floating points. And array isn't a standalone built-in type either.
So how do you handle collections then?
You use internal tables for that. They are incredibly powerful.
Ah, okay.
But the deeper insight here is why defining these types precisely matters so much. It's not just about saving memory, though that's part of it.
What else?
It's about data integrity. ensuring the system knows exactly what kind of data it's holding. It prevents silly errors, makes sure calculations are right. It's foundational.
Foundational data integrity. Got it. Okay, so we've covered these basic building blocks: data access, object creation, data types. But enterprise software isn't built in a vacuum, right?
Not at all.
It has to fit into these bigger modern architectures. How has ABAP kept up? Especially when it comes to, say, exposing data to other systems or front ends.
Yeah, this is where things get really interesting, especially with the newer frameworks like the RESTful Application Programming Model, RAP.
RAP. Heard a lot about that.
It's significant. And for exposing data in a controlled, flexible way within RAP, you have something called the projection view.
Projection view.
Yeah.
Okay, what's special about that?
Well, it's not just about showing data. The real insight is how it lets developers create these tailored data contracts.
Tailored contracts.
Yeah. Imagine you have complex business data underneath. The projection view lets you expose only the specific fields needed for a particular API or UI. You can even combine fields from different sources.
So you customize the output for each consumer.
Exactly. It's like a chef making specific meals from one kitchen pantry, depending on who's eating. Keeps things clean, only relevant data goes out. Super important for modern interconnected apps.
That sounds incredibly useful for API design.
Yeah.
Lots of control.
Now, thinking about flexibility inside the code, making sure you can swap parts out or add new features without breaking everything.
Yeah.
What about ABAP interfaces? What are their key traits?
Interfaces are absolutely key for that kind of flexibility and making systems extensible.
How so?
Well, the core idea is they define method signatures, what a class should do, but they don't provide the actual code, the implementation.
Just the contract.
Just the contract. And a crucial characteristic is that multiple different classes can implement the same interface.
Okay.
This promotes what we call loose coupling. Components interact through the interface. They don't need to know the nitty-gritty details of each other's code.
Like a standard plug.
Exactly like a standard plug. Think USB. One standard interface, tons of different devices connect seamlessly. Interfaces enable polymorphism too, treating different objects uniformly. It leads to much more robust, adaptable software. That USB analogy really clicks. Okay, so we've got modular components, modern data exposure, flexible design. But what does this all mean for actually building reliable systems?
Right, systems that don't fall over, run fast, and keep data secure.
Yeah. Let's shift there. First up, errors. Things inevitably go wrong sometimes. How does ABAP handle runtime errors gracefully?
Graceful error handling is, well, non-negotiable, really.
Yeah.
For system stability, user experience, everything.
So what's the mechanism?
ABAP uses the TROI.catch construct. You put the code that might cause an issue inside the TROI block.
Okay.
If an error and exception happens during execution, the system doesn't just crash.
Which is good.
Very good. Instead, control jumps to the corresponding key TH block. This lets developers anticipate problems, maybe a network failure, a bad user input, whatever.
And react to it.
And react. Log the error, notify someone, tell the user what happened, maybe let them try again. It's the difference between a system breaking completely and one that guides you through a hiccup. Preserves data, preserves sanity.
Definitely seen the bad alternative. So graceful error handling is vital. Now, once it's built and handling errors, how do you ensure it's actually fast? Especially those database interactions. What tools help with that?
Performance tuning, especially the database side. For that, the go-to tool is the SQL trace. Transaction ST05.
ST05, SQL trace.
Yep, it's indispensable. It basically records every single database statement your ABAP program executes.
Every single one.
Every one. But the real power isn't just seeing the list. It's analyzing how long each one took, how many times it ran.
Finding the slow ones.
Exactly. It lets you pinpoint precisely which SQL queries are inefficient, maybe being called way too often. Those are often the culprits behind a sluggish system. I've seen cases where one bad query slows everything down. ST05 finds those performance vampires.
Performance vampires. I like that. It's like a diagnostic tool for your code's engine. Okay, so that's for specific query tuning. What about broader code quality, like ensuring code meets standards before it even gets deployed?
Right, more holistic checks. For that, you've got the ABP Test Cockpit, or ATC.
ATC, ABAP Test Cockpit.
Think of it as a comprehensive quality gate. Every serious ABAP application should go through it.
What is that?
All sorts of things. Syntax errors, obviously, but also potential performance pitfalls, adherence to coding standards, security vulnerabilities, a whole range.
So it's not just about bugs.
No, it's proactive. It's about ensuring consistency, making sure the code is maintainable, secure, scalable across potentially huge code bases. It's like that rigorous pre-flight checklist for an airplane. Got to pass ATC before takeoff.
Makes sense. Essential for enterprise quality. And thinking even earlier in the process, preventing bugs at the component level. How do developers test individual pieces of code? What's a local test class?
Ah, yes, unit testing. A local test class is exactly for that.
Okay.
It's an ABAP class you define right there in the same program or include file, but it's separate from the actual production code.
Is its purpose?
Its sole purpose is to run automated tests against small, isolated bits of your logic, like a specific method or function module.
Wow.
Being local makes it easy to create and run. The real benefit is letting developers quickly check if their specific piece works exactly as intended over and over without messing with the main system or needing complex data setups.
So it boosts confidence and speed?
Massively. Increases confidence, speeds up development, and helps ensure future changes don't accidentally break something that used to work, like having a mini lab for every component you build.
Mini lab. Nice. Okay, finally, let's hit security. Absolutely critical, non-negotiable in the enterprise world. How does ABAP control who can do what? Access sensitive data, run certain functions, that whole least privilege idea.
Right. Least privilege. Super important. In ABAP, the core mechanism for this is authorization objects.
Authorization objects.
Yeah, these are quite granular and define specific fields and the values within those fields that are checked for permissions.
How does that work in practice?
Well, when a program runs, say, trying to display sensitive customer data or approve a large payment, the system performs an authorization check. It looks at the relevant authorization object and compares the values in the object against the user's assigned permissions.
So it checks if this specific user is allowed to see this specific data or perform this specific action.
Exactly. It's not just a simple yes-no for the whole program. It's fine-grained control. The deep insight here is that these objects are the foundation of a sophisticated role-based security model.
Role-based, meaning users get permissions based on their job role.
Precisely. You ensure users only get access to exactly what they need for their job and absolutely nothing more. The challenge often isn't the mechanism itself, but designing the roles and maintaining those authorizations correctly. Getting that wrong can leave big security holes.
So they're like the digital keys and locks.
Perfect analogy. They're the keys and locks of the entire enterprise system, and managing them carefully is paramount.
Well, thank you for joining us on this deep dive today. We hope you keep exploring the fascinating world of technology and beyond.